Sound is produced when an object vibrates and causes the air around it to move. The source of sound can be imagined to be like a pulsating sphere, radiating spherical waves. As the sphere pulsates, it will alternately compress and rarefy the surrounding air, resulting in a series of compressions and rarefactions traveling away from the sphere. These are known as longitudinal waves, since the air particles move in the same dimension as the direction of wave travel. The alternative to longitudinal wave motion is transverse wave motion, such as is found in vibrating strings, where the motion of the string is at right angle to the direction of apparent wave travel. Sound arrives at the ear in the form of periodic variations in atmospheric pressure, called sound pressure waves. Likewise, as a vibrating mass, such as a guitar string, a person's vocal cords, or even a loudspeaker, moves outward from its normal resting state, it squeezes air molecules into a compressed area away from the sound source. This causes the area being acted on to have a greater than normal atmospheric pressure, a process called compression. As the vibrating mass moves inward from its normal resting state, an area with lower than normal atmospheric pressure will be created. That's a process called rarefaction.
A waveform is essentially the graphic representation of a sound pressure level or voltage level as it moves through a medium over time. The distance above or below the centerline of a waveform represents the amplitude level of that signal. The greater the distance or displacement from that centerline, the more intense the pressure variation, electrical signal level, or physical displacement will be within a medium. Waveform amplitudes can be measured in several ways. The measurement of either the maximum positive or negative signal level of a wave is called its peak amplitude value. The total measurement of the positive and negative peak signal levels is called the peak-to-peak value. The rate at which an acoustic generator, electrical signal or vibrating mass repeats within a cycle of positive and negative amplitude is known as the frequency of that signal. It is the number of waves emitted, or received, in 1 second. One completed excursion of a wave is known as a cycle. The number of cycles that occur within a second is measured in hertz. The time it takes to complete one cycle is called the period of the wave. The wavelength of a waveform is the physical distance in a medium between the beginning and the end of a cycle. It is frequently represented by the Greek letter lambda. With any wave, the distance between corresponding points on successive waves is its wavelength.